Welcome back, Algebra 2 students, to another Regents review video. This is the Algebra 2 Common Core Regents exam for the August 2016 administration. This is the second exam of Algebra 2 Common Core. These are going to be the solutions to Part 1. Questions 1 through 12 of this exam. So, before we begin, as usual, do not take these answers and cheat, because it's not a good idea. Duh. It's Algebra 2. It's a hard exam, so you gotta, try the problems by yourself before you come here and look at my stuff. Make sure you hit that subscribe button down below. Consider becoming a patron on my Patreon page, and visit my website at www.nysmathregentsprep.com. Both of those links, the Patreon page and my link to my website, are in the description below. And before we begin this exam, don't forget that I use the TI Inspire CX Calculator. Powerful tool. I highly recommend it. It can be found on my website. The link takes you right to Amazon or the Texas Instrument page. Without further ado, let's begin. Number 1. We begin with not a hard question, not an easy question, but an annoying question. Which equation has 1 minus I as a solution? Okay, so you're given all of these quadratic equations, okay? And you need to do either completing the square or the quadratic formula to get 1 minus I as a solution. So here's the thing. The way, or the fastest way to get this answer, because you don't want to be doing the quadratic formula 4 times. You just don't want to do it. So the best way, first, is to graph them. Graph them all. And what are you looking for when you graph them? Well, if you graph them, you're looking for a parabola that is above the x-axis. It's above the x-axis, so it could look like this, it could look like this, it could look like this. Any one of those. It cannot be touching the x-axis, and if it does, then it has a real root, okay? So if I go to my graphing calculator, and I go to my graph page, I'm going to graph everything. So x squared plus 2x minus 2. I'm going to graph x squared plus 2x plus 2. Get that. And we get x squared minus 2x minus 2. And we get x squared. Oops. And we get x squared minus 2x plus 2. Okay. So if you look at all your graphs, the blue quadratic and the black quadratic are not the answer because these parabolas cross the x-axis. We want the red and the pink ones up here. See how the red is above the x-axis and the pink is above the x-axis? That produces imaginary roots because the discriminant is less than the number 0. So we know immediately it cannot be choices 1 and 3. Now we're down to 2 and 4. So now it's easy. Just go ahead and perform the quadratic formula on these two, okay? So let's go ahead and do that. Let's take a look at choice 2, and let's perform the quadratic formula. So we got x equals negative b plus minus the square root of b squared minus 4ac all over 2a. Okay? In this case, your a is 1, b is 2, c is 2. X is equal to negative 2 plus minus the square root of 2 squared minus 4 times 1 times 2 all over 2 times 1. Continuing on, we get x is equal to negative 2 plus minus the square root of 4 minus 8 all over 2. That gives you x is equal to, let's see, negative 2 plus or minus the square root of negative 4 all over 2. The square root of negative 2 is, the square root of negative 4 is 2i. So we get negative 2 plus minus 2i all over 2. And all of these 2's can reduce to the number 1. So your answer is negative 1 plus or minus I. Okay? So that's your answer to choice 2. But we're looking for 1 minus I, not negative 1 minus I. So choice 2 is actually incorrect. Your answer is choice 4. And let me just confirm it with you that that is the correct answer. And then I'll show you how to do it in the graphing calculator because it's a fast way. But you got to know how to do the math. So let's go ahead and do the quadratic formula again. X is equal to negative b plus minus the square root of b squared minus 4ac all over 2a. So we get, let's see, negative and negative 2. Watch your signs. Plus or minus the square root of negative 2 squared minus 4 times 1 times 2 all over 2 times 1. So we get x is equal to positive 2 plus minus the square root. This, when you simplify this, this will give you the square root of negative 4 all over 2. We get 2 plus or minus 2i all over 2, and we get 1 plus or minus I. And you could take the negative, 1 minus I is a solution. Your answer is choice 4. Let's just say that you didn't know how to do that, but you should know how to do it. But I could show you how to do it on the graphing calculator. Go to your graphing calculator and go to your calculator page. Click on Menu, go to Algebra, click on Polynomial Tools, and find the complex roots of the polynomial. I'm going to type in x squared minus 2x plus 2, comma x. Boom! 1 minus I. Solution. Done. Your answer is choice 4. Moving on to number 2. Which statement or statements about statistical studies is true? So option 1 says that a survey of all English classes in a high school would be a good sample to determine the number of hours students throughout the school spend studying. Okay. Let's see if that is true or false later down the road. Choice 2 says a survey of all 9th graders in a high school would be a good sample to determine the number of student parking spaces needed at the high school. Option 3 says a survey of all students in one lunch period in a high school would be a good sample to determine the number of hours adults spend on social media websites. And option 4 says a survey of all calculus students in a high school would be a good sample to determine the number of students throughout the school who don't like math. Okay. Let's go through each one. A survey of all English classes in a high school would be a good sample to determine the number of hours students throughout the school spend studying. Would that be a good fit? And the answer is yes, because it specifically says in the problem a survey of all English classes. All English classes. That means every single class in the high school. That means you're surveying 9th graders, 10th graders, 11th graders, 12th graders. That means that you were asking kids who are in like advanced levels as in honors classes or humanities. You're asking in AP level courses. You're asking for the regular courses, and you are asking kids who are in remedial courses. So that's a large, diverse group of people. Okay, so this is a large, diverse group of people. We want large and diverse. So that's true. That's a true statement. Let's take a look at option 2. A survey of all 9th graders in a high school would be a good sample to determine the number of student parking spaces needed at the high school. Really? When's the last time 9th graders drive? Not okay, because 9th graders don't drive. Let's take a look at option 3. A survey of all students in one lunch period in a high school would be a good sample to determine the number of hours adults spend on social media websites. What do kids have any knowledge of with adults spending time on social media websites? That makes absolutely no sense. I don't know where they're getting that from. And option 4 says a survey of all calculus students in a high school would be a good sample to determine the number of students throughout the school who don't like math. Now, you have to know what calculus is. I mean, you should know that calculus is like the highest level of math you could take in high school. So, kids in calculus are kids who do like math. Okay? Students who are in calculus probably are in there just because they like the subject of mathematics. So, why would that be a good sample for people who don't like math? That makes no sense. So your answer is choice 1. The only one that works is the survey of all English classes, because that is a large and diverse group. All right, moving on to question number 3. To the nearest tenth, the value of x that satisfies 2 raised to the x equals negative 2x plus 11 is what? So here's the thing. There's really only one way that I recommend to solve this, and that is called numerical solve on your calculator. Okay? Numerical solve on the calculator. You could also graph this. You could graph 2 raised to the x, and you could graph that line and get it. So that's perfectly fine as well. But if you go to graphing calculator, go to the calculator page, click on menu, go to algebra, then click on numerical solve, and just type it in. 2 raised to the x equals negative 2x plus 11, comma x. Your answer is 2.55, which is 2.6 when you round it off. 2.6 is the answer. Done with that question. Moving on to number 4. The lifespan of a 60-watt light bulb produced by a company is normally distributed with a mean of 1450 hours and a standard deviation of 8.5 hours. If a 60-watt light bulb produced by this company is selected at random, what is the probability that its lifespan will be between 1440 and 1465? So what should be ringing in your head is normal CDF on the calculator. Normal CDF on the calculator. So what you're going to do is you are going to evaluate the lower bound. You're going to evaluate the upper bound. Then we are looking at the mean, which is also denoted by the letter mu, mu. And we're looking for the standard deviation. So the lower bound, well, it's asking for between 1440 and 1465. So the lower bound is 1440. The upper bound is 1465. Your mean, they tell you, is 1450. And your standard deviation is 8.5. Take all that information, plug it into your calculator, see what you get. All right, here we go. Go to your calculator page, go to menu, go down to statistics, go to distributions, and go to normal CDF. The lower bound is 1440. Upper bound is 1465. The average, or the mean in this case is 1450, and the standard deviation is 8.5. Why is it not doing it? 8.5. Click OK. We get 84%. 0.84. 84%, which is choice 3. Done. Moving on to number 5. Ooh, this one's toughy. This one's tough. Here we go. Which factorization is incorrect? Which factorization is incorrect? So, you basically need to take all of these and factor them. So let's go ahead and do that, shall we? Let's take a look at choice 1. Let's go ahead and factor choice 1. So factoring choice 1 requires your knowledge of the difference of two perfect squares. So let's go ahead and do that. We have 4k squared minus 49. Let's apply the difference of two perfect squares, dots. Okay? When you take the square root of each, square root of 4 is 2. 2. Square root of k squared is k. The square root of 49 is 7. Put a plus minus in between. That's your answer. Does it match up here? Yes, it does. So that is correct. We're looking for the one that's incorrect. Let's take a look at choice 2. So choice 2 is showing SOAP factoring, or SOAP factoring is when you have perfect cubes. So what you do for SOAP factoring, let me tell you. SOAP factoring is when you take the cubed root of these numbers. So the cube root of 8 to the third is a. The cube root of 8 is 2, and the cube root of b to the third is b. Now, what does SOAP mean? Well, SOAP means same sign when you take the cube root. The same sign, if it's negative, it's still negative. Then you set up your trinomial, okay? Now, here's the tricky part about SOAP. You know that the letter a times this over here, the first term of that trinomial, has to equal a to the third. Well, a times what gives you a to the third? Well, that's just a squared. Okay, that's good. Now, negative 2b times what gives you negative 8b? Well, that's going to be positive 4b squared. Okay? And what goes in between? Well, the in-between, or the middle term, is always the multiplication of these two numbers here. So the positive 1 and the negative 2. When you multiply those together, you get negative 2. But the problem is when you do SOAP, the SOAP method, it's the same sign, and this is going to be the opposite sign. So if it's negative here, it has to be positive. All right? And you just toss on the AB. So this is your answer. Okay? So SOAP again, same sign, opposite sign, and the AP means always positive at the very end. That's always a positive number. Okay? So let's go ahead and check and see if that is the answer. Does it match up there? Yes, it does. So we know that we are correct. Sweet. So we know that choice 2 is not the answer. Let's go on to choice 3. Here we go. Let's go and factor m to the cube plus 3m squared minus 4m plus 12. It looks like that we are going to be doing group factoring, just because there's 4 terms. So I'm going to group this. I'm going to group this. So when you group factor, you get, you take out a GCF first. So you take out an m squared. You're left with m plus 3. Now over here, you take out a GCF. So you have to be quite careful how you do this. So let's take out a 4. You know that this binomial has to match with this binomial. So this has to be m plus 3, right? Let's make sure. If I take positive 4, if I make this a positive 4, and I redistribute back in, I should get 4m plus 12, right? If you distribute in that 4. But the problem is it doesn't match this. That's negative 4m plus 12. So that doesn't work. So let's try a negative answer. Let's try negative 4. So we distribute that in. We get negative 4m minus 12. Okay, well that doesn't match still. It's negative 4m plus 12, not negative 4m minus 12. So therefore, ladies and gentlemen, we cannot group factor this. This totally wipes out. We can't factor by grouping, so we can't group factor. So there actually is no answer to this. You see how they force it to be m plus 3? But we just realized that there's no way to get that 4 to be positive or negative. It can't work. So your answer is choice 3. Okay? Now, I'm going to show you how to do choice 4 just because I know most of you are probably like, I don't even know how to factor that. Let me show you how to do choice 4. Choice 4, this one's nasty. Choice 4 is actually, you factor by grouping with 3 terms. Yeah, I said it. You're going to factor this with 3 terms. Let me rewrite it down here. So choice 4 shows t cubed plus 5t squared plus 6t plus t squared plus 5t plus 6. So what you're going to do is you're actually going to group factor 3 terms. Okay? Take out the GCF over here. The GCF is t. You're left with t squared plus 5t plus 6, right? Now this, the GCF here is positive 1, so take out a plus 1, and you're left with t squared plus 5t plus 6. The same rules apply. These have to match, all right? In this case, they're trinomials, but these trinomials have to match. So now what you're going to do is you are going to factor those trinomials by using the AM method of factoring. So what adds to 5 and multiplies to 6? What adds to 5 and multiplies to 6? Well, those are, let's see, those are t plus 3 and t plus 2. That t is still up front. Plus 1 times t plus 3, t plus 2. So now what we're going to do, when you group factor, you combine the t and the 1. The t plus 3 and the t plus 3 you only write once. And the t plus 2 and the t plus 2 you only write once. So your answer is t plus 1, t plus 2, t plus 3. That's how you factor it using the group factor method with 3. And look at that. That is the answer to that part. So that, oh man, that is a hard way to group factor. Most of you probably have never seen that before. And, yeah, just know how to do it. That is actually on the Facts You Must Know Cold guide. It will be on the updated version. All right, number 6. Sally's High School is planning their spring musical. The revenue R generated can be determined by the function R of t equals negative 33t squared plus 360t, where t represents the price of a ticket. The production cost C of the musical is represented by the function C of t equals 700 plus 5t. What is the highest ticket price to the nearest dollar they could charge in order to not lose money on the event? So here's the thing, folks. We have a revenue function, okay? We have a revenue function right here. And we have a cost function. What we're doing here, and this is actually knowledge from Algebra 1 as well. Do you remember revenue minus the cost equals the profit right? Remember what these words mean. Revenue is how much money you earn. Cost is the amount of money spent to produce the thing. And the profit is how much money you take home after everything's paid off, okay? So here's what we got to do. We want the revenue function to be greater than or equal to the cost function. What does that mean? Well, the revenue function, this function up here, must be greater than the cost function or equal to the cost function in order to not lose money. They don't want to lose any money. Now, that doesn't mean that they want to earn a profit. You got to be careful with the wording here. Profit means that they want to bring something home. If they said profit, this would be greater than only. But they don't want to lose money on the event. So it could be equal to the cost function as well. They could produce it and walk away with nothing. Unfortunately, you don't want to do that. You want to always earn something. But they just don't want to lose money on the event. So what we're going to do is we're going to substitute this for R of t and this for C of t. And we're going to solve it. Let's do it. So we get negative 33t squared plus 360 t is greater than or equal to 700 plus 5t. Okay? Let's go ahead and solve for t. We're going to, what are we going to do? I guess we could subtract the 700 and subtract the 5t. Subtract the 700 and subtract the 5t. Okay? So we get negative 33t squared plus 355t minus 700 is greater than or equal to 0. Now, here's the thing. That is a really, really messy thing to factor. So here's the thing. What you really should do is you should actually set this equal to 0 and find the roots of this function. Remember what this is, ladies and gentlemen. This is now the profit function because I just took the revenue, which was over here, and I subtracted over the expenses. So this is actually a revenue function. So what I'm going to do is I'm going to go to my graphing calculator. I'm going to go to my calculator page, and I'm going to find the roots. So go to Menu, Algebra, Polynomial Tools, find the roots of this polynomial. Let's do it. Just typing all this in. Oops, 355 x minus 700, comma x. Okay, so these are your roots, the 2.6 and the 8.15. So, here we go. What do those mean? Well, these are the ticket prices. The ticket prices that they could charge is t equals $2.60 or $8.16. Well, obviously, what is the highest ticket price that they could charge and not lose money in the event? Well, they could charge $8.16, which is approximately equal to $8. And that's how you do that question, folks. Honestly, not too bad. Moving on to number 7. The set of data in the table below shows the results of a survey on the number of messages that people of different ages text on their cell phones each month. If a person from this survey is selected at random, what is the probability that the person texts over 50 messages per month, given that the person is between the ages of 23 and 60? Okay, so what we're really finding is we're finding the probability. All right, we're finding the probability of 50 messages, given that the age is between 23 and 60. Okay, so 50 messages over. So between. Hold on one second. So over 50 messages a month is in this column. And the person is over the age of, or sorry, in between the ages of 23 to 60. If you go across the row and the column, you get 157 people. Okay? So we know that our numerators are correct. So what is the denominator? Well, how many people are in the age group of 23 to 60? Well, there's 25 plus 47 plus 157. There's a total of 229 people in the 23 to 60 age group. So your answer is actually 157 over 229. Your answer for this one is going to be choice 1. That 312 is a trick answer. It's a trick answer because what they wanted, they were going to see, will you add these numbers together? But that's not true because these are for all of the age groups. If you add up that column, you should be adding up the row of 23 to 60 age group. All right, moving on to number 8. A recursive formula for the sequence 8, 9, 4.5, all the way down is what? So, recursion. Recursion means that you're given the first term of the sequence. Well, we could actually knock out a couple answers. Knock out choices 2 and 4 because those are not recursion formulas. Those are explicit forms. We're not given the first term. We need to be given the first term. In this case, is over here and over here. So now what we're going to do is we're going to find the pattern. Well, it's decreasing all the way down, and you're multiplying each number by 1/2. So your answer for this one is choice 1. There's that 1/2. We're not multiplying by 2. We're not going 1836 and going up by doubles. We're not doing that. We're counting by half. So your answer for this one is choice 1. Number 9. Kristen wants to increase her running endurance. According to experts, a gradual mileage increase of 10% per week can reduce the risk of injury. If Kristen runs 8 miles in week 1, which expression can help her find the total number of miles she will have to run over the course of her 6-week training program? So here's the thing, okay? We were told that she runs 8 miles in week 1. So when n is equal to 1, she ran 8 miles. Okay? She wants to increase it 10%. So what's happening here is we are trying to find the summation, the total, the summation of the miles. So what we're doing is we're applying exponential growth. Remember the formula A of t equals the principal times 1 plus or minus the rate raised to the t power? Yeah, I know. It came back to bite you in the butt. So, the principal, which is this initial amount, she started off with 8 miles per week. She's increasing the amount. So, it's 1 plus the rate, which is 0.10 for 10%, raised to the t minus 1. Why is it minus 1? Because we already took into account for the first week. The first week is 8 miles. If we just put the letter t, that means when time t equals 0, she already ran 8 miles. How does she run 8 miles if there's no time? Right? That doesn't make any sense. So you need to subtract 1 from it. And we're trying to find the summation from 1 week to 6 weeks. Your answer is choice 1. That's a summation. If we're looking at these answers, choices 3 and 4, that actually shows a decrease. If you were to input these numbers, that shows a decrease. And the reason why it's a decrease is, look at this. This number in here shows a decrease, and this number shows a decrease. So that's wrong. And this one over choice 2 over here, they're failing to subtract a 1 because they're not taking into account of the initial value. So that's why it's going to be choice 1. Number 10. A sine function increasing through the origin can be used to model light waves. Violet light has a wavelength of 400 nanometers. Over which interval is the height of the wave decreasing only? So what you're doing here is you're just going to draw a quick sketch of a sine graph. I'm going to draw it to the best of my ability. Hopefully I do it well. Honestly, not too bad. Could be a little bit better, though. Nah, that'll do. Okay. So, it has a wavelength of 400 nanometers. So, a wavelength is from the starting to the stopping. So, this whole thing is 400. Now, what's nice is 400 is a nice even number. We could actually split this as 100, 200, 300, 400. Okay? So, what we're doing here is we're looking at the interval that is decreasing. All right, we're decreasing. So the interval that's decreasing is from 100 down to 300. That's it. It's increasing on these intervals over here. So your answer is from 100 to 300. Choice 2. Not too bad of a question. Moving on to number 11. Please know how to do synthetic division. I think the synthetic division is significantly easier than polynomial division. So in order to do synthetic division, you're going to set the denominator equal to 0 and solve for x. We get x equals -2, right? We're going to take that -2, we're going to put it in the little box up here. And I'm going to take the coefficients of my polynomial in the numerator. That's 1, 2, 1, and 6. Okay? Draw your line here. Draw a line below. Bring down that 1. Now, synthetic division, we just perform the operations. We're going to multiply these two numbers. -2 times 1 gives you -2. Then we're going to add those up. 2 plus -2, we get 0. 0 times -2 is 0. 1 plus 0 is 1. 1 times -2 is -2. 6 plus -2 is 4. So, remember, you need to know the division algorithm. Don't forget it. It's going to bite you in the butt if you do forget it, because it's on most exams. The division algorithm. The division algorithm states it's your quotient, which is your answer, plus the remainder over the divisor. That's how you write your answer. So the quotient is actually here. It's the coefficients of your variables. So you see how we started with an x to the third? When you perform synthetic division, everything drops by 1 degree. So therefore, since we started off with x to the third, this one over here is actually going to be x squared. So this is an x squared term, this is an x term, and this is a constant. Well, x, there's nothing for the x term, so it's x squared plus 1 plus the remainder of 4 over the divisor. The divisor is what you're dividing by, x plus 2. And that, ladies and gentlemen, is your answer. X squared plus 1 plus 4 divided by x plus 2. Your answer is choice 2 for that question. Last question of the video, number 12. A candidate for political office commissioned a poll. His staff received responses from 900 likely voters, and 55% of them said that they would vote for the candidate. The staff then considered a simulation of 1,000 more polls for 900 voters, assuming that 55% of the voters would vote for their candidate. The output of the simulation shown in the diagram below. Okay. Given their output and assuming a 95% confidence level, the margin of error for the poll is closest to what? So you need to know the margin of error formula. Okay? Here we go. The margin of error formula is this. It is your z-score. It's your z-score times the square root of p times 1 minus p divided by n. Let me tell you what those letters mean. So the z-score, it's just a number, and I'll explain that a little bit later. So these letters that you see over here, p means the percent expressed as a decimal. Okay? And the letter n represents the number of voters. So the number of voters is 900 people, and the percent is 55. Convert that to a decimal, 0.55. So, okay, here we go. The z-score. What is the z-score? Well, the z-score, you need to know that it directly relates to the confidence level. If you have a 95% confidence level, the z-score is equal to 1.96. And if you're asking yourself, Trevor, do I need to memorize my z-scores? Yes, you do. But what's nice is there's only 3 z-scores that you need to know, okay? And that's all given on my Facts You Must Know code for the Algebra 2 Regents. Know it. 95% confidence level, z-score is 1.96. You could even think and round it up to 2 if you want to. Let's just say you can't remember 1.96. You could say it is 2. You're going to get around the same answer, okay? So let's go and plug this stuff in. So the z-score, I'm going to put it over here, margin of error. The z-score is 1.96 times the square root of 0.55 times 1 minus 0.55 divided by number of voters, 900. So the margin of error is, when you plug this into your calculator, let me plug it in. So, let's see. 1.96 times the square root, control division, 0.55. 1 minus 0.55. 1 minus 0.55. Divided by 900 people. Your answer is 0.03. 0.03. That answer is choice 2. And you are done with that question. And that is the conclusion of the video. I hope that you enjoyed the content that I produced for this time around. Make sure to hit that subscribe button down below. Consider becoming a patron on my Patreon page. And visit my website at www.nysmathregionsprep.com. Both those links can be found in the description below. I have a lot more content in Algebra 2 on my website and in your future high school math subjects such as calculus. And I hope to see you soon.